This recording brought to you by the University of Adelaide.
One thing I'm going to do is I'm going to show that a lot of the things that we've heard earlier today sort of mesh in together, because physics is a strangely small community, and somehow people that we've been talking about today have been part of my life as well, and over the last 40 or 45, quite a few years. One more year, I think, than Tanya said, unfortunately. It's, there you go. So one thing that Bruce Dawson and I did in the 1990s was produce a little book, which looks like that when it's in Chinese, but it's actually Cosmic Bullets, which is a book for people who want to know a little bit about cosmic rays and in a wordy sort of way, and that's my style of doing the teaching stuff, and I was very pleased that Bruce and I were able to do this. We did it on a suggestion from Paul Davis, so that's one connection with one of the talks that we've had early. That Paul, of course, was very keen to be part of the published community, and Paul edited a series of books, and this was one that he asked us to do. And people in the business quite like it. It's one of those books that you can actually read a little bit, as opposed to the serious cosmic ray books that tell you the real stuff, which are good for putting you to sleep, but perhaps not so good for reading. So Cosmic Bullets is the end point of this talk, if you like. It was in the early 1990s, and it sort of listed all the things that Bruce and I and John Patterson and Alan Gregory and all of these guys who collectively, if I can find the little button, collectively became called the Cosmic Ray Good Guys Club, which we'll meet from time to time in this, because it seems to me that I didn't know how a research group should run when we came here. I came with John Prescott, who I assume knew how a research group should run. Maybe he was only slightly ahead of me at that time, but I learned about the running of research groups through these guys, through the CRGGC, through the students that we had, and learning what worked with them and maybe what didn't always work with them, but developing an esprit de corps, I think, which has stuck together. And the scary thing about the CRGGC thing is that the CRGGC, as far as I can see, is currently defending Australia, and I'm sure we're in good hands. There we are. Okay. So I'm going to say a little bit about what happened when I came here with John Prescott, and in doing that I'll have to go back a little before that time. But basically this is the synopsis, and we can. If you can remember this, then when Tanya terminates me in just a few minutes' time, that'll be the final story. So before we came here, Ken McCracken was here, and with his X-ray and gamma ray and cosmic ray astrophysics, should have said cosmic ray there. John Prescott and I came in 1971. John replaced Ken in some sense. Ken had resigned, and I presume that the chair was advertised, and my assumption looking back on it is that John had come here and given a talk, as one does when one applies for a chair, and he'd been successful, and I'll explain to you a little later why I believe that's what happened. I was naive enough not to realize that at the time. Then that was with Alan Gregory and myself and John Prescott. We brought equipment from Canada to come here. I was working with John in Calgary. John Patterson joined us a little later, and from that time we built a cosmic ray system at Buckland Park, the Buckland Park air shower array, and after a few years we all diverged a little bit. John moved into archaeometry, John Prescott, John Patterson and Alan moved rather more to the gamma ray studies, and so the area of interest that we have spread. And one of the notes that I think Bruce perhaps put in the little introductory leaflet that you've got is that we ended up with some groups that were of a critical mass. The critical mass for us was 3 or 4 people, which, to be honest, in modern time physics isn't a critical mass. The groups that we work in now are the Pierre Auger Observatory, 450 scientists, IceCube, Hess. These are major international collaborations. You can't, it's very, very difficult in experimental physics to manage with just 3 or 4 people yet. We felt that that was a critical mass, and that was a number that, that Alistair, who I've now lost, Alistair felt was suitable, and indeed it was suitable over this era. So we're talking about a group of 3 or 4 people interested in astrophysics and trying to do what we now call high-energy astrophysics. So we then moved on, and by 1990, which is the end of this little bit of the story, Bruce had joined us, and we moved on to join the Pierre Auger collaboration, having been a member of another collaboration in the US called HiRes. So that's the general synopsis of where we were, and so the sort of flow of this is that Ken McCracken had his X-ray and cosmic ray astrophysics group. He'd left, and we inherited some space, which was then called the Cosmic Ray Lab, and we studied radio air showers here at Adelaide. That moved on to gamma ray air showers with John particularly, and Alan, and we also did gamma ray work, which is what you did in the 1980s with air shower arrays. Learned a lot about statistics, learned a lot about physics, learned next to no astrophysics as a result of it, and we continue to do what we were doing then. So, Graham, I think, talked about Bernard Lovell. Bernard Lovell was one of the people who set up, as Graham said, the Jodrell Bank research station. The guy who was with him was a guy called John Clegg. John Clegg happened to be the person who taught me electromagnetism at Imperial College, and John would wander backwards and forwards, which is a habit that I got into in lecturing backwards and forwards along here. The other habit I didn't get into was that he chain smoked all the way through the lectures, which you can't do nowadays. But he'd actually written the manual for radar in the Second World War. So that's another connection with the things from that Ian was talking about and Graham was talking about, this small community of physicists. So he'd been with Lovell when Jodrell Bank was set up, and he was a bit of a hero of mine, and I wanted to do radio astronomy, so I went to John and said, well, how about if we do some radio astronomy? And he said, no, I don't really do any research now. How about if you find someone else? And there was a guy who was probably the world's poorest lecturer at Imperial College then, a guy called Harold Allen. And Harold was my second hero. Harold got halfway through a lecture course on solid-state physics and then decided that he either didn't understand it or he got it wrong anyway. And so we went back to square one, and then we had another go at it. I'm not sure if it was right in the end or not, but it didn't matter, because Harold was one of those great physicists who does things as we should do, goes on to, starts from square one, says, what's the physics of what I'm trying to do, and just works through with it. Harold didn't, we did radio emission from air showers. Harold didn't really understand antennas, but once he understood that an antenna radiating electromagnetic waves was very much like a nucleus emitting a neutron, he could understand it pretty well then, because that's what he knew a lot about. So physics is a little picture here, which you transfer to another little picture there, and then it works, and so that's what we were doing. We came here to do astrophysics, and to be honest, I knew no astrophysics when I came. I was the age of 25 at that stage, totally naive, but we'd done okay at Imperial College, and at Imperial College I'd worked with Harold, and John Prescott had come and spent study leave at Imperial College. Study leave's another of these themes that we've been talking about today, just how important study leave is. And at Imperial College, John and Harold Allen had got together to discuss radio emission from cosmic ray showers. As you sit here, there's around 100 particles a second going through your body, which are called cosmic rays. They were discovered, strangely enough, 100 years ago this month by a balloon flight. where people measured the amount of radiation there was, radioactivity if you like, as you go up in a balloon, and as you go away from the surface of the Earth, that amount of radiation drops off. But you get up to a certain height, and then it gets more and more and more when you go above that height, such that when you're flying in a 747, the radiation level is probably 5 times what it is here at ground level. And as Ken pointed out, if you go out into space and you're going to the moon or you're going to Mars or whatever, the radiation levels are serious issues for you. So cosmic rays are radiation that fills space. The highest energy cosmic rays come and they interact with the Earth's atmosphere. They deposit their energy in the Earth's atmosphere, and a cascade of secondary particles travels through the air to the ground. And the trick to study those particles is to study the cascades of particles as they come through the ground. We call those extensive air showers, and we built a system at Buckland Park, the Buckland Park Array, to study extensive air showers. So that's what John and I were doing when we came. Now, you can study those things when the particles hit the ground, when they go through your body or whatever, but what you'd really like to do is to know what's happening as that energy travels through the atmosphere. And that means you've got to have some way of observing the cascade as it comes through the atmosphere. A couple of ways of doing it. One is to look at the light that it emits in coming through the atmosphere, Cherenkov radiation, and that's a technique that, that was used by Big Rat and at White Cliffs for doing gamma ray work with big light collectors. But you can also have a radio receiver that simply measures the electromagnetic field of that cascade as it comes through the atmosphere. The atmosphere has got the geomagnetic field in it, and this cascade of particles coming down through the geomagnetic field. The positive particles go one way, the negative particles go the other way. You get a dipole, and dipoles, just like on the top of Mount Lofty, will transmit radio waves. And so the idea is to pick up these radio waves. And we spent a lot of time, I spent my PhD studying those electromagnetic waves, that radio emission from air showers. That's what we did. Bruce and I are members of the Pierre Roget collaboration, and the collaboration is now studying cosmic rays at the very, very highest energies, at 10 to the 20 eV if you want to be technical, huge energies. And the people there are doing radio studies, and they were just amazed to discover that we'd already done it 40 years ago. And as a member of the publication committee, they're quite surprised where I pick them up when they've missed out referencing work that they should have been referencing. That was back to the real pioneers. So those are the things that we've done. Cast of characters, of course, are the group that we've had of various people, and happily many of those people are in here at the moment, so you can spot a few of the casts of the characters there. Well-known Bruce Dawson, in case he looks, sorry Bruce, Pete Gahardy, and various people, as I mentioned, who are currently saving the world from disaster. But of course, the most important people, and the people who haven't really been mentioned very much today, and I'm really sad about that, are the people who make all of this experimental work operate. And that, for us, was Ern Hindley, who worked with Ken building or helping to build those balloon packages, and of course, Neville. Neville's got to be here somewhere. Promised me he'd come. I don't know where he is. And Neville Wild, of course, who works with us at the moment. Without those people, we couldn't operate. Okay, and without in an earlier era of the workshop, which is now wound down quite a bit, we couldn't have operated either. These are the people that make it all possible, and it's about time we sang their praises a bit. And Ern, as you can see, is a social sort of guy, and that makes the group work. That made this Cosmic Ray Good Guys Club into a Cosmic Ray Good Guys Club because people did stick together, and when you stick together, of course, there's a common enemy, and I shan't mention that. Okay. Well, Leighton Barnden's here somewhere, Barney, and this is from his thesis. That was studying as, hi Barney, yeah, as Ken said, you can study the heliosphere by the motion of cosmic rays sloshing through the heliosphere. And there's some really great calculations in Barney's thesis, but we do the same thing at the moment. Here's a muon from a couple of days ago. Here's a muon detector doing the same thing. I just missed the back end of a 4-bush decrease because I was too slow. There was a good one about 3 weeks ago. Here's a 4-bush decrease, a coronal mass emission from the sun causes the total cosmic radiation at the Earth to change. We still do those things. They're still interesting, and I think they're still important. NASA's currently flying some satellites to study the Van Allen belts, for instance, because they are so important. We do calculations like this as well. Follow charged particles through magnetic fields that you specify. Here are the magnetic fields in the solar system, and here are trajectories of cosmic rays moving through those magnetic fields. The last guy to get a PhD with us was actually doing calculations just like that, except here was the galaxy, the Milky Way galaxy, and here was the outer parts of the universe. We still do the same things. They're still important calculations. Well, I went to do my PhD postdoctoral work with John Prescott. John had got excited by radio emission from air showers, talking to Harold Allen, and John was in Calgary, and we used a radio telescope in Penticton, British Columbia, and here's the radio telescope, a 22 megahertz frequency, and basically we took a little slab of it, and to be honest, I can't remember where it was, but probably down there, took a number of those dipoles, and we measured cosmic ray showers coming past those dipoles, and we measured the electric field in those dipoles. And John, in fact, demonstrated that this geomagnetic effect was the origin of the emission of the radio emission. Well, I said that. I mean, I did that as well for my PhD, okay, so. But John certainly did that, and the people at the Pierre Auger Observatory in 2012 are still trying to prove that, but that's how it is, folks. The local animals here are things like rattlesnakes. Buckland Park, they're brown snakes, okay. Poisonous spiders there, poisonous spiders at Buckland Park. You can see the relationship between these sorts of places. Well, John must have given a lecture as part of getting the position here at Adelaide, because I was a bit surprised to actually arrive at Adelaide to discover that Tom Stubbs, with the array that Ian and Graham had described at Buckland Park, had already done this experiment. He'd looked at Cherenkov emission from cosmic ray showers to detect the showers, and he'd actually measured with the 2 megahertz array at Buckland Park, he measured radio emission from cosmic ray showers. Now, I'm sure he would have done that as a result of John Prescott giving this talk for getting the chair here at Adelaide. So in retrospect, I'm sad that we didn't continue with the 2 megahertz array there, because I think we could have done some pretty interesting physics there. Tom and later David Felgate used a pair of old searchlight mirrors pointing at the sky to pick out the Cherenkov light from the cascades coming through the atmosphere. That was traditionally called the bug-eyed monster. Phil Edwards has promised me a picture of the bug-eyed monster, but I haven't got it, and he can't find it. But Alan Gregory and I wanted to use some simple light collectors at one stage, and so we made some fiberglass copies of that and as molds, and then we made some little searchlight mirror results of that, and here they are. We use them down in the Bragg labs for showing sound being focused by similar mirrors. Okay, so there's the great Buckland Park air shower array. Radiation detectors on the ground in around 1975. Those radiation detectors consist of large amounts of plastic that emit light when particles go through them. Fast photomultipliers up there. I was sort of naive because I thought that everybody knew how to make fast photomultipliers and how to make them work. And we learned how to do that the hard way, and then discovered that other people didn't actually know how to do that, and that we were, strangely enough, as the people at Pierre Auger call us, we were pioneers. Didn't feel like being pioneers at the time, but that was how it was. Buckland Park grew, and we added more and more detectors to it over the years, with some quite fancy stuff, and I think it was Ian that pointed out that they had a fancy Nova computer. Well, we had a fancy Nova computer too, okay? We had we had some fancy stuff as well that went with it. I think theirs was better than ours, but I wouldn't care to admit that. But there were some nice things in here. Double discriminator. People know where they were when President Kennedy was shot. Maybe you weren't born then, but if you were born, you knew where you were. You knew where you were when people landed on the moon. I can't remember those things, but I can remember inventing that. It was at McDonald's down in Mitcham with the children down there. They were playing in the playground there, and I was sitting. How on earth do you get a photomultiplier to give you sub-nanosecond timing? And Neville and I built that. Okay. We use that sub-nanosecond timing to find the directions of these showers. They travel at the speed of light, and so as they come, the time at which they arrive progressively changes, and you can get directions from that. And the direction that we got was about 1 degree good, which is pretty good for what we thought we were doing, which was gamma ray astronomy. I didn't know any astrophysics when I got here. John Carver and possibly Graham said that Brian Horton and I were going to teach astrophysics. Brian knew some. I read his notes and totally confused me, so we made it up as we went along. But we set up Astronomy 1. And in 1976, there was an eclipse. We all went down to Mount Gambier, and a great time was had by all, a member of the CRGGC there, Dave. Shows your thumb. Good. And so that was in Sky and Telescope. There's a little picture, the little Sky and Telescope over there that shows that. So it was all part of a community that was building up. We were learning to do astrophysics from a very naive point of view, but also learning to enjoy life. And somebody said, oh, we haven't seen a picture of Anne Venn. There's Anne, I think, there. Other important people who used to run the department and do vital things, apart from the ladies that we met this morning, of course. We actually used to have a lab there. Sorry, Greg. We used to have a lab there, and we were thrown out of that about 1990 when Jesper came, so note of bitterness in there. Okay. In the late 70s, John Prescott developed an interest in thermoluminescent dating, and this gentleman is also here, and you can search very hard and find him around here. And one of the things that we were always doing in that era, we were always using equipment that no one else in Australia had got at any stage. And one of those things in the first era was the classic personal electronic transactor. Was that the PET? Yeah. Fine machine. For many years, it was the only machine that we'd got that would actually drive a Camac system, because it had a bus that you could do that with. So we kept these things running for a lot longer than we ever should. But John made a fantastic contribution to thermoluminescent work, developing the spectrometer that he used. And had some classic papers on that. So John moved out of the group, I guess, in many senses in the early 80s to do his thermoluminescent work, which continues to be incredibly successful. And of course, as we all know, you had to have that one, didn't you? Yeah, let's face it. The CRGGC was a very important group of people, sometimes apologetic for its behavior in the bar. Sometimes it wanted to insist that the barmaid got reinstated or got more time because it liked the barmaid. And occasionally it was very social and invited Prince Charles to come over for a barbecue at Buckland Park. And Bruce was very concerned when the governor came. I think if we'd known what the protocol was, that letter would probably never have got sent by a person who was to become the chief scientist for the Navy, was it? So we moved on, and John Patterson in particular and Alan Gregory had an interest in doing gamma ray astronomy, which you could do with Cherenkov systems. And that was pioneering work. And this was done, first of all, in a serious way at White Cliffs. White Cliffs had a solar power station. It's a little town in the middle of almost nowhere, the other side of Broken Hill. Go down to Wilcannia and drive very fast past there in a northerly direction, and you end up at White Cliffs. And these light collectors were ideal for doing gamma ray astronomy, Cherenkov gamma ray astronomy, run by the ANU actually, but provided solar power in the, I guess, the 1980s for the little township of White Cliffs. That developed into one of the, in my opinion, less fortunate acronyms. The Big RAT was the Bicentennial Gamma Ray Telescope, and okay. I mean, we've had some great acronyms, but like Kangaroo, which, and I presume Phil invented that. Did he? Was that a Phil, or was it one of yours, John? Alan Gregory. Apologies, Alan. Sorry. So this was at Woomera, and it had a little camera on it, which was developed. It turns out that the camera wasn't good enough, but nobody knew what was good enough in that era. It wasn't until the 1990s with Whipple, which is one place that Dave was at, when we started to know how to do this sort of work. So this was pioneering work, set up at Woomera. There's Big RAT, and here's a group of hangers-on, I suppose. At least two of them were hangers-on, I'm pretty sure, and the other one was a person who was supposed to be there. But and this was at Woomera before the rest of the Kangaroo system was built. Okay. It's a problem, isn't it? You go out there and you keep your fingers crossed that the skies are going to be clear, and Woomera very often they are. Argentina less often, but you always hope for clear skies. And sometimes, just very quickly go through this for anyone who might recognize the handwriting. If you've got a huge light collector, you don't run it in the daytime necessarily where the sun goes on it and can cause conflagration here and there. The cosmic ray spectrum covers a huge range of energies, and we've had some attempts to run at different energies. And here was some data that we got. We're looking at lower energies. Phil Edwards there, Claire Karani there. The people who are members of the Institute of Physics would know there's a Claire Karani Prize. For many of us, it brings a tear to our eye just thinking of Claire. Claire's life was tragic and cut short very tragically. Somebody mentioned the Observatory Lecture Theatre. Here's the great Observatory Lecture Theatre. I used to love lecturing in there. Then it became the childcare centre. So there you go. But John and Ray, of course, Ray joined us in the 1980s and gave us underpinning, theoretical underpinning, which was vital to us and brought great fame to the group. Buckland Park had its scintillators in these Hertz, which are currently being, as we speak, I think, being destroyed or being removed. Yeah, okay. And wrap up. Okay, here we are. Okay, and in the end of the 1980s, we were trying to think what is the future, and a future appeared to be neutrino astrophysics, and a suitable detector appeared to be the Blue Lake at Mount Gambier. And the idea of putting black plastic over the top of the Blue Lake in Mount Gambier was probably naive on our part. Okay, but we did investigate, and Gary and Janice investigated using the Blue Lake as a neutrino detector. Well, that didn't work out, but Gary currently does work at IceCube, is a senior person at IceCube. The gamma ray work has now led to people like Gavin being with us, working on Hertz, which is the world's superior and very, very best gamma ray telescope, the best neutrino telescope in the world, and the best cosmic ray observatory in the world. Thanks.